And we'll use that information to solve for v a with respect to b, which also equals the magnitude of b with respect to a, because these are magnitudes, they don't care about direction. And this value is equal to 80, this value is equal to 60, and we can plug all of that in. Squared times 80 squared plus 60 squared minus 2 times 80 times 60 times cosine of 135. In the end, we will find that the velocity of A with respect to B equals 129.6 kilometers per hour. And let's go ahead and convert that to A with respect to B to meters per second, and we'll get 36.0 meters per second. This is the first third of the problem. We've now successfully solved for the velocity of A with respect to B. However, this isn't a full vector. To get the full vector for the next part, we also need to solve for direction. And we will use the law of sines to do that. And that means that we have 129.6 over sine of 135 equal to 80 over sine of beta. And I'm identifying this angle as beta. And in the end, we'll find that that angle beta is equal to 25.9 degrees. So now we have a full vector. This is the end of the new part for this section. Next, we're going to be converting this vector into spherical coordinates, which earlier sections of this chapter you've done a lot before. And let's not forget what this problem is. With the velocity of A over here, the velocity of B over here. We just identified the velocity of A with respect to B and connected it to the velocity of A with beta. And the rest of the problem wants us to find r dot and theta dot, with this vector being r times theta dot. Now that we have these coordinates, it is just a matter of sine and cosine to get theta dot and r dot. For r theta dot, we get that it is 36.0 times cosine of 25.9. When you divide by r, you get that it is over 300. And theta dot ends up being 0.1079 radians per second. Then r dot is similar, in that you solve for 36.0 times sine of 25.9, and that ends up being r dot equal negative 15.71 meters per second. In this problem, we started out with velocity of A and B, connected them to each other, and used that relative velocity and turning it into polar coordinates.